Hello and welcome to Numeristical. Today we are going to review the Moneyline model and its performance over the season and break down, dig into the data, break down how we did in particular teams, how we did in favorites versus underdogs, all that kind of stuff. So thanks to everyone who watched my previous video where we went through the totals model. The totals model, of course, was a good performing model. We were up 10 units for the season on that model. The Moneyline model was not so good, so let's start diving into that. So this model had, noticeably worse performance. It was down 12.75 units for the season. But we're going to dig in and try to diagnose some of the problems and try to see, some tips for how we might have improved the model or what might be going on. So we load in our data, and just to take a look at the last 9 bets or so. So just to catch up, I'd never reviewed the last day of performance. In the last day of performance, we had 2 bets, both big underdogs, and we won one of them. The Royals beat the Braves at plus 215 that the model had picked. So we had a nice pickup there. So we had a small rally at the end of the season. We were down like 15, 16 units, something like that. And it rallied to be down just 12.75 units. So just doing some processing. So you see, we bet 237 times on the money line. 7 of them were rainouts. Of the remaining 230 bets, we won 94 and we lost 136. So we won with a probability of 40.87%. Now, we were mostly betting underdogs, so that might not be too bad, but unfortunately, our average implied probability across all our bets was 42.93%. So we were betting underdogs, but our not quite to the extent where a 40.87% win probability would have been good. So we lost 12.75 units across all our bets. That's that number right here, or rather, that's the number right here. Then, if you break it down, one thing you do is break it down by month. So kind of see how we did month by month. And you see we got off to a terrible start. And then it kind of did a little better, or at least, middling. But then at the end of the season, it also did poorly. Around early July, we were actually pretty good. The Moneyline model was actually up. But then it fell from there. What were some adjustments we made over the season? So one adjustment I made early, when we had this bad performance early on. So I remember March, this is just like a few days. So just a few days into the season, did very poorly. And one thing I realized is I needed to avoid the model predictions and pitchers that didn't have a lot of experience. So at the beginning, I wasn't doing that. And that's something that's obvious in retrospect, but I just didn't think to do it when I was starting. So, clearly the way the model works, the way I set it up to do is, when it doesn't have a lot of history on a pitcher, it kind of fills in the history with like kind of an average to below average pitcher. So I did make this adjustment for people like Yamamoto and Shoto Imanaga. I quickly said, okay, I'm not going to bet against these guys because, these are clearly very strong pitchers, and my model doesn't know that yet because it doesn't have any history of them. So it's just treating them like every other kind of rookie or unknown pitcher. But I should have gone further, and I eventually did, of just saying, hey, when I don't know the pitchers, the Vegas bookies probably know more about how good this pitcher is than the model does. So I should really just avoid those situations until I really have enough, data on the pitcher that I can argue, hey, I've got some data on this pitcher's performance, and maybe the model is actually crunching that data better than sort of the odds makers who are operating a little more heuristically. So that was the main adjustment we made. I think I also did change the model a little bit at some point again around late May, when I was changing the totals model. I think I did make an update at that point to the Moneyline model. Okay, so now what teams did we bet on the most? And if you've been following the channel, this should be no surprise. The number 1 team the model bet on was the White Sox. 21 times we bet on the White Sox. And obviously this was not the season to be betting on the White Sox. The next team that bet on the most was the Athletics. And then interestingly, the Mets were in there. So you see these first 5 teams, you've got, 4 of the worst teams in the majors, and then the Mets. And actually, if you go down even further to the Marlins, you see we had kind of like the 5, I think they were the 5 worst teams in the majors. There's certainly the White Sox, Rockies, Angels, and Marlins were the 4 worst teams. I don't know if the Athletics were actually the 5th worst team. But then you have the Mets and the Reds, who were the Mets are a playoff team, and the Reds were, about a 500 team. And these were the teams the model bet on the most. Only one team we never bet on was actually the San Francisco Giants, which is kind of funny because I live in the Bay Area. But not once did the model choose to bet on the Giants. And you see teams at the bottom here, the teams we bet on the least. And, the Yankees, some strong teams like the Yankees and the Dodgers and the Orioles were very rare to bet on. The Braves also. So a lot of the teams that were highly rated going into the season did not get bet on a lot. Now, who did we bet against? So interestingly, the Dodgers and the Giants. So, the Dodgers, maybe not surprising that we bet against them a lot. They were a very well-regarded team. They had a very good season, obviously. I think 98 wins they ended at. But, they were expected to be a super powerhouse. I think the over-under on their wins was over 100 if you were betting at the beginning of the season. So there's actually a team that was a very good team, very highly rated, but to some degree underperformed, and largely because of their pitching. They had some injuries and so forth, and their pitching sort of underperformed. Their offense was still quite strong. And then the Giants and the Orioles, the Blue Jays, the Guardians. This was interesting. Obviously, the Guardians were a team that really overperformed this season. Did much better than they were expected to do going into the season. But generally, we were betting against largely good teams. I mean, not exclusively, but largely. If you look at this top list, the Giants were a 500 team. Blue Jays were not very good, but the rest of these teams were all strong teams. And the Mets, actually, bet against the Mets a fair amount. So anyway, that's interesting to look at. Now, what was our performance like? This is who we bet on or who we bet against. Let's look at our performance when betting on or against these teams. So we're ranking these by who we made the most money off of on the top and who we lost the most money on at the bottom. And you see, interestingly, the Reds, we made a lot of money on the Reds. We bet on them 15 times, so, somewhat of a significant number. Again, all these numbers are small, so you got to take all this with a grain of salt. But we went 10 and 5 on the Reds, betting an average implied probability of 43.8. So you're generally betting them as an underdogs and winning 10 out of 5. So we picked up 7.7 units just betting on the Reds. Next was the Phillies. Phillies were a very good team. We didn't bet them that much. When we did bet them, they tended to be underdogs. And we went 6 and 2 on the 8 times we bet them. And then the Pirates and the Marlins. The Marlins were sort of a comeback. If you go back up, we won with them twice in like the last 3 or 4 games of the season as underdogs. So they were probably like -1 until the last 2 games, and then we picked up quite a few units with them at the very end. But not too much else to see here. The Rays, we were about even money. We bet them 12 times. We bet them 12 times. Not much else. Pirates, kind of a team that, a middling team, but maybe a team that maybe overperformed a little bit at the beginning of the season. I think they were stronger than people expected them to be. Now, if we scroll to the bottom, kind of no surprise if you've been following the channel. We got creamed on our White Sox bets. We lost 5.7 units. We bet on them 21 times, only won 5 times. And so we only won 23.8% of our bets, and we bet on them as if they were going to win 35% of those games. And next, the Angels also were pretty bad for us. We bet them 15 times, went 4-11, and the Rockies as well. So if you're following this channel, you would hear me groan, particularly for the White Sox and the Rockies. I do a lot of groaning when the model told me to bet on them. So, and if you look at these three, just these last three, who were three of the four worst teams in the majors, that's 15 plus units right there that the model lost betting these teams. So I think there's something to be said that, there's a lot of ways you can unpack this, but, we definitely had a season where we picked the underdogs too much. The model had too much confidence in the underdogs, and the underdogs did not come through. And I think there's a few things you can say about that. One, the White Sox were sort of a historically bad team. I mean, the worst team kind of ever. So it's possible that in the training data, the model just never saw a team that was this bad, and so always thought, hey, even the worst team's going to win, 30, 33, 35% of the time, and didn't consider that didn't have it in its data that a team would be this bad. So that's one possibility. Could also just be luck. Again, these are not huge numbers, right? And it would only take a couple more wins in each of these to throw the numbers another way. So you have to realize that the variance when you're betting underdogs is also a lot much higher. So that's another thing to consider. If we had won a couple of the 250 plus 250 bets, all of a sudden we're close to even with the White Sox. Interestingly, the Athletics here, we only lost 1.62 units with them. This was another team that the model was betting a lot, particularly early in the season, and kind of getting creamed on. But eventually we did 19 bets on them, and we lost 1.62 units. We didn't do terribly on them. So that's it. The Mets, I think, is the other notable thing. We bet on the Mets a lot, but we actually lost money on them. And this is an interesting case where we were betting on them largely, at pretty good odds. 48.6 means, you have always got the VIG. So 48.6 means on balance, they were basically slightly favored, I would say, because minus the VIG, you'd be at like 47.6. If you were betting minus 110 every time, that would mean they were even money every time. You'd be at like, I think 47.6. So the Mets were kind of favorites. Or maybe I said that wrong. Anyway, Mets sort of broke the trend in terms of a team I bet on a lot, lost money on. They were not, obviously, a bad team that I was betting as heavy underdogs primarily. So this is interesting, I think, just to see just the degree to which these three teams killed me. And if you took out the bottom four teams, again, this is a year we had four teams with 99 losses or more, which I think is pretty rare in baseball history to have that many teams. We had four teams with 99 or more losses and no teams with 99 or more wins. So it was a season where you had very bad teams, but actually not really very good teams. There's a lot more balance at the top of the pack. So, and just want to point out the Marlins. The Marlins were the other team. We actually made money on them. But if you took out the four worst teams in the league, even though the Marlins were plus 2.59, that was pretty much our losses. If you took out those four teams, this would have been a break-even model. Wouldn't have been profitable, but it would have been about a break-even model. Okay, let's move on to now teams we bet against. And here are the teams we bet against the most and made the most money. So interestingly, the Blue Jays. We bet against the Blue Jays 15 times, went 10-5, and made 7.7 units betting against the Blue Jays. Next up is the Yankees. This is perhaps less surprising, right? You think of the Yankees as a team that's very popular, probably gets a lot of money bet on them due to their very strong following. So you can imagine the model might find spots where they're kind of overrated or over predicted to win. And again, only 12 bets, but we went 8-4. And, they were, when we were betting against the Yankees, we were betting at a 41% implied probability. The Brewers, this is interesting also. I probably wouldn't have expected that, but we made a lot of money betting against the Brewers. And then the Braves and the Phillies. So again, and the Giants. So interesting, the model really didn't like the Giants. It never bet on them, and it bet against them a lot. So that's sort of interesting. Now, who did we lose money betting against? The Dodgers and the Guardians, right? These are the big two that we lost a lot of money betting against. We bet against the Dodgers a lot, 17 times, and we only won 4 times. And we dumped 6.5 units doing that. And the Guardians, perhaps less surprising. This is a team, again, that overperformed. I think a lot of this was early in the season. So we were betting against them before, when they were not thought to be a very good team. And again, this might be a situation where perhaps the bookies kind of adjusted more quickly maybe than the model does. The model's looking at, big, long windows of history for the most part, and it doesn't change its opinion too quickly. And there might have been something where perhaps the bookies said, kind of more quickly recognized, hey, this team's actually pretty good. And, made some adjustments, and the model was still kind of thinking they were bad. So that's it. The Rays, interesting, we only bet on them 8 times, but every time we bet against them, except for one, we lost. So that's also interesting how badly that went. But other than that, I don't think there's really big lessons to draw on here. We bet against the Mets. We just had trouble with the Mets. When we bet for them, they lost. And when we bet against them, they lost. I remember there was a certain point where the model really liked Jose Quintana, was betting on him almost every time, and really did not like Luis Severino, just was almost betting against him almost every time. And looks like that did not play out the way the model thought it was. Not sure what was going on there. But anyway, so these are the numbers. This is who we made and lost money against. Then I went to look at particular pairs of teams. And I looked for pairs of teams that we bet on this particular pair of teams to win, specifically a team to win and a team to lose, that particular ordered pair, where we bet on it more than 3 times, just to kind of look. So actually the most common pair we bet on was the White Sox to beat the Guardians. And actually, we bet on it 6 times. The White Sox actually won 2 out of the 6. So it actually ended up being, we lost almost a unit. But this is obviously, they won 33% of the time, and by the implied probability, they should have won 35% of the time. So it kind of played out as expected. We wouldn't say we lost a lot of money there. But here you see the A's Guardians, we were 0 for 3. A's Mariners, we were 0 for 3. Rockies Giants, we were 0 for 3. Angels Astros, we were 0 for 3. That was late in the season, I think. It was 3 times in a row. The model picked the Angels over the Astros and lost all 3. So the ones where we won, Reds Dodgers, over the course of the season. Anyway, not sure there's a lot. The numbers are too small to really read too much into that, but I was just curious to see whether anything really jumped out there. All right, now I want to look into, in general, betting favorites versus underdogs. How did this break out? So let me explain this table a little bit. I took the implied probability and just converted it into an integer. So 24 means roughly an implied probability of 0.24. And I spaced these out at 4. So this 24 actually means between 0.22 and 0.26. This 28 means an implied probability of between 0.26 and 0.3. and so forth. And this line equivalent is then saying, here's kind of the midpoint of the line. So when I was betting around plus 316s, these very big underdogs, here is my performance. This 0.28 converts to a 257 line. The 0.40 converts to a 150 line, and so forth. So the idea being, at the bottom of this are when I was betting favorites, and at the top of this was betting, the really big underdogs, and then these are like the mild underdogs. So one interesting thing that jumps out is when the model mostly is picking underdogs, when it did pick a favorite, it tended to do pretty well. We bet 41 times as a favorite, and mostly in this sort of 52 to 55% range of implied probability. And we won 60% of the time, on 40 some odd bets. Not a huge sample, but something, not a tiny sample. So I thought that was interesting. When the model did pick a favorite, it tended to do pretty well. And where we got creamed, interestingly, was underdogs in general, but it was really like this range was particularly bad. So when we were betting at like, around around 120 to like 140, this is where we got creamed. Plus 120 to plus 140 on the money line. We bet 57 times. And, we only won 31% of the time. The average implied probability was about 43%, 43.8%. And we only won 31% of the time on 57 bets, which is a pretty sizable number to have a decent sample size, for this kind of analysis. So see, we actually did better. We actually had a higher winning percentage betting the bigger underdogs at like, 140 to 160. We actually won more of those. So again, still relatively small sample sizes. I don't think you could say that much here, except to say that when it bet favorites, it tended to do okay, especially given that we lost so much as underdogs. We were up about 5 units when we bet favorites. When we lost 17 when we bet underdogs. Okay, I wanted to do again the same kind of analysis in terms of how likely is it that the model is right versus the bookie. So I do the same kind of evaluation. I say, what's the probability of all the outcomes we saw under what I estimate to be the bookie's probability, and how do we do based on what I estimate to be sort of the adjusted model probability. So assuming I had like a 3-point edge when I took a bet, 3-point edge on the line probability. And what you see is these numbers are inverses of each other. So this means that the bookie probability, the data was 3.36 times more likely under the bookie probability than under the adjusted model probability. So if you remember when I did the totals model, in the totals model, it was like 2.7 in favor of the model. So this is 3.3 in favor of the bookie. So it's even stronger evidence that kind of the model was not good and that the bookies were right for the Moneyline model, overall across all these bets. And, so on the face of it, just like it looked like the model overall was not doing well. And that would be interesting. I didn't go through the exercise of trying to break down maybe favorites versus underdogs, or stripping out those bottom 4 teams. So you could argue that maybe the model had some power in those regions. Again, you have to be careful because you could always find some subset. If you find enough different ways to divide it, you could always find a way that like your model did well on this subset. So you have to be a little careful about and being honest with yourself about is that real or not. So if you were just to take the overall model, though, overall basically the bookies seem to be right and the models seem to be wrong. And to illustrate this even more, I did some simulations. Let me let these run. They don't take too long to run. But what I did was I said, I took the bets that I made and I generated probabilities for each team winning or losing based on the bookies' probabilities and then based on the model's probabilities. And I looked at how much my set of bets would have won or lost in each of those situations and where my outcome fell within that. So first, under the bookie probabilities, so if the bookie probabilities are right, here's 50,000 simulations of how my set of bets would have done. So you see there's some chance I would have made 25 units, even if the bookies are right. It's a small chance, but you know, there's some percentage chance where I just get lucky. The bookies were right, my model was not doing anything right, but I still made 25 units or even profited, right? There's still a pretty good probability that I would have profited even if I was totally wrong and the bookie probabilities were right. But you see, where I landed was almost like dead center. It was like dead center of what the bookies would have predicted that I would have won or lost on the money line. And if you look at what I would have won or lost if my model, if those model adjusted probabilities were actually right, here's the range of outcomes. So it's, you know, it's kind of like either the bookies were right and I got, you know, the almost exact expected value of what you would expect to happen in that case, or the model was right and I got really, really unlucky, right? And I ended up with this outcome out here in the tails. So again, more evidence to say that, you know, the model did not seem to have, overall, seems to have predictive power in this case. And then I did one more simulation to say, what if the betting line was right? So this would be a world where when I bet on something, it was more likely than the bookies thought, but not enough to overcome the vig. So it was exactly, I was picking break-even bets. My model was good enough to find a set of bets where I would break even, but not good enough, but not strong enough of an edge to actually make money. And there you see kind of falls in the middle. It's, you know, I should have, again, the zero's kind of right in the center here. So the most likely thing would have been for me to break even, kind of by definition. And you could see losing 12 units would have been, yeah, you know, on the unlucky half, but not super duper unlucky. So anyway, I thought this was an interesting analysis. I mean, if I wanted to dig deeper, I would really try to dig into, you know, the favorites, looking at favorites and looking at, you know, dropping those certain teams. And again, there was some noise at the beginning as I adjusted the model. Early on, right, the statistics on players are not very accurate, right? So you're trying to use a player's past to determine how they're going to do now, and a lot changes in the off season, right? And as you get more data from the season, it should presumably get better. So, you know, take all that how you will. I think there are things I could do to sort of go back and retool and improve this Moneyline model, but clearly this season it was not a profitable model, and you know, clearly seemed to be doing badly with the underdogs. I think that's what you can take home. It did bad with the underdogs, did bad. It overpredicted the probability of these very good teams, of these very bad teams. And, you know, that's kind of what cost us money. And at the same time, not a lot of evidence that it was doing stuff right. The only evidence where you saw it was doing stuff right is maybe when it picked favorites, because it was sort of tilted to underdogs. When it picked favorites, there was actually a pretty big edge there. So there might be something to learn there. That's all I got for today. I hope you found this interesting. I'm going to do one more with the spreads model, which is probably going to look very similar to what we saw here with the money line, but I'll break that down as well. And thanks for joining me, and I'll see you in the next video. Bye-bye.